Hi, Professor. This is our project. The name of our project is Improvement of Delivery Process in E-commerce Company. And we have 6 group members in our group. We'll list there. And I will go to our agenda part to describe our project. So I will describe our project 4 steps. The first one is background, the second one is problem, the third one is analysis, and the last one is improvement. I will describe our project shortly. There are some problems of this e-commerce company. It's just like the delayed delivery process, and they cannot complete every order in one day. So the orders will accumulate every day, and it will affect the unstable of this system, and maybe someday this system will fall out. So after that, the customers will not satisfied with this company. So our project, the objectives of this project is to decrease the delivery time and decrease WIP level, and also complete every orders before 7 o'clock. So I will describe the background detailing. With a high development of e-commerce business, so customers prefer to buy products online, and we choose this background to do a research about e-commerce company. This e-commerce company is running the baby products. They buy the baby products offline and sell the products online to get some profits. And this company also cooperated with the Shunfeng Express. Shunfeng Express will arrive at 7 o'clock to pick up all the orders. So we would better to finish every orders before the 7 o'clock. And the workers will be off worker at 7 o'clock every day. So the last situation is the 2013 August. The orders will sharply increase from 300 to 500 products. So that's the whole part of the situation of the background. So after the background things, we do the forecast. In this graph, we see the 2 lines. The right line is the real orders every day, and the orange line is our forecast. So we see they matching to each other, and we also do the forecasting here. We use the 85 days before data to forecast the products in the future. So after that, we find some problems. The first is that we found some problems. So the first is that the low warehouse space, but the high WIP, because we increase the products from 300 to 500, and the orders arriving in every hour keep increasing. We see that in that graph is a little bit increasing. And the third one is that disorganized process of picking and packaging in the delivery process. So they will affect the long queuing time for the new orders. And this is the 4 significant problems of this company. So we need to do some analysis and do some improvement to solve these problems. And I will pass to Vivi to do the analysis part. Thank you.
Okay, thank you, Cassie. Our projects focus on to reduce the cycle time of the delivery process. There are 3 stations over the delivery process. They are check, pick, and package. The orders go through the 3 stations and then be outputted. Okay, the system can be regarded as a CONWIP system. The orders coming from the online service system come into the system and then be checked, be picked, and then be packaged. Also, there is a WIP cap, which limited the total WIP level in the system. That's because the warehouse space in the company is very limited. Okay, we learned some algorithm in the class for this model, and we can use this algorithm to calculate in different WIP level. There will be different CT cycle time for different stations, and we can calculate the WIP for different stations. Okay, we mainly have 3 products: the bassinet, the toy, and the diaper. The large size bassinet accounts for 50% of the total amount of sales, and the middle size product accounts for 30%, and the small size product account for 20%. So they have a BB of 5, 2, 3, 2, 2, 2, and each product has a different effective processing time in each station. We can see in this table, the large size product may have 2.5 minutes in the peak process, but the middle size product only need 1.9 minutes to be picked. So we sampled a normal flow of orders and study it. We found the average effective processing time of each station will be like this. The average effective processing time of a check is 0.8 minutes, and that of the peak process will be 2.14, and so on. And we also found out the coefficient of variance of the effective processing time, CE, to different stations. Then, use the algorithm and the data we have, we can figure out this table. This means when the system owns different W levels, the CT, the changing CT and the WIP of each station. So use this table, we can find use the above table, and we gather data from the company to get the average flow in each hour during one day. Because the workers will stop work after 7 p.m. So the unhandled orders in the previous day will be pushed to the next day morning, and the company wants to deal the unhandled orders in previous afternoon and evening in the morning, about 3 hours, and we will handle it. So we average the unhandled amount of orders in the previous day to the next day morning, and the WIP level will be shown like this. And by according to the algorithm, we can find the CT and WIP of different stations. We will find the station packaging will have the largest CT and WIP, so we will focus on the improvement of the packaging process. Daniel will introduce some solutions. Thank you.
Okay, next we move on to the improvement part. So basically we have 3 solutions to solve our problems. So the first solution is to add workers to our process. So in that way, we hopefully the recycle time will be reduced and we will increase the rate as well as the efficiency. So okay, the next solution is we plan to extend our working time for our workers. So originally, our working time is from 9 a.m. to 7 p.m. So we plan to prolong the normal working time to 9 p.m. So which means that we naturally increase 2 hours working time for our workers, hopefully, and this will solve all the orders one day. Okay. So the next solution is we provide a training course to our workers. In that way, our workers' average working time will be reduced to like 17% compared to the original working time. Another part is that we can also hire some supervisors to regulate our workers in terms of the leisure time. Like sometimes they want to smoke, they want to break down. So that would decrease our efficiency. So we will spend more money to hire some supervisors to regulate them. Okay. Next slide. So after a series of calculations, we have our conclusions. So if we look at the first picture, we could find that the solution 2 did not work, because if you see the red line, you can easily find that even if we extend our working time, there's still like around 15 orders left for each day. So that would result in the unfinished orders are still likely to be accumulated every day, and our entire company will explode. Okay. But if we look at solution 2 and the solution 3, we can find that both solutions can perfectly solve our problems in terms of the unfinished orders in 7 p.m. is about to 0. Okay, so but if we compare with the cost, we can find that the solution 1 will cost like 19,000 RMB per year, and the solution 3 will cost like 75,000 RMB per year. So it would give us a quite straightforward conclusion that the solution 3 is much more economical. So here we have our conclusions that the best solution to balance the improvement of delivery process and the economic benefit is to provide training course to our current workers, as well as hiring some supervisors in regulating their leisure time, just to ensure they are reached to their maximum efficiency. Okay. But still, we're gonna have some limitations. Basically, we have 4 kinds of limitations. The first limitation is that we lack of certain data. It's quite serious because if you lack of the data, you cannot go in deep analysis. So basically, we have just conduct a quite fundamental and quite basic analysis. The second limitation is assumptions. So So basically, we assume that there is low failure time of our workers and the machines. But in the real world, no matter the people, the human and the machine, will sometimes have fails due to a lot of factors. The third limitation is we ignore the values brought by workforce. That's because we lack this kind of data to address this problem. The final limitation is that the recycle time is estimated according to a separate order. So sometimes the sample is not the direct reflections of the real data. So it would kind of give us inaccurate result. Okay, thank you so much.